My presentation will be on the experience of cooperative intelligent transport systems in France, which is not as advanced as the one in Japan. In Europe, we are just starting what we call, well, starting not. We are fully in what we call pilot deployments. That is to say, several thousands of vehicles equipped and equipped in real conditions, and we have an evaluation of the benefits afterwards before full-scale deployment. However, the main difference between what you've seen and what we are doing is that we also support direct vehicle-to-vehicle vehicle-to-vehicle communication. And this is the way we define CITS in Europe. So CITS in Europe means delivering services through the exchange of information between vehicles, V2V, or between vehicle and infrastructure, V2I or I2V. So the V2I or I2V part is very similar to what you've just seen. The vehicle-to-vehicle part is, for example, when you have a vehicle that experiences an end of queue, an emergency brake, an accident, a breakdown, a slippery road, they can detect that automatically and automatically trigger a message that is sent and that is received by the vehicles that are just before, even if there are several vehicles in between, and they receive the information that pops up and they can brake or adapt their driving to that condition. That's the same information is also sent to the road operator. That's the V2I part. And the I2V part is that the road operator can also send information such as the current status of roadworks or winter maintenance or so on. Why do we invest on CITS in France? First, to improve road safety. I think that the examples I've given on slippery roads, accidents, and so on are quite convincing. It's also to optimize traffic management, because it's something that has been quite documented and proved that drivers usually trust more what's inside their vehicle on their HMI rather than what's outside on variable message signs, for example. So it's more efficient for traffic information. It's also about optimizing infrastructure management costs, because through probe vehicle data, as has also been shown by the previous speaker, we can invest less on counting loops, for example. Even in the end, maybe less variable message signs, because the information would be directly inside the vehicle. We can also offer new services to the drivers, such as information on parking areas, availability of parking areas, for example. This is something that can be added to the road safety services. And it also helps lay the foundations of vehicle of tomorrow. The role of CITS for automation has already been shown. I would just add one example based on V2V communications. Usually, automated cars don't see very far. Their sight is around 200 meters ahead. And so when there's an end of queue, they will brake very sharply. And if they get the information through connectivity before, through V2V communications, they can anticipate and brake more smoothly. So in France, we are investing in a pilot deployment project called SCOOPATEF, or for cooperative system in France. In a nutshell, the project has started in 2014, will end in the end of this year. It's co-funded 50% by the European Commission. It intends to connect 3,000 vehicles with 2,000 kilometers of road network, various configurations of roads. We have motorways, we have urban expressways, we also have bidirectional roads in the countryside, also in the mountains, with the influence of the topography also. We have two deployment waves. The first wave, that is actually the 3,000 vehicles that are mentioned and that are now deployed, is based on what we called ITSG5 in France. It's a dedicated short-range communication technology operating in the 5.9 gigahertz band, so just nearby the 5.8 gigahertz. And that deployment is based on priority services. You will have the list of the services in the next slide. The second wave is rather a proof of concept of how we can hybridate ITSG5 communications with cellular networks, so with 3G or 4G networks. And by the way, we also add new services, but we just prove that on a few vehicles, and it's not a full-scale deployment. And the services we have chosen as priority services are there to improve road user and also road operator safety. So that's the main focus we have here. Not only road user safety, but also the safety of the road workers on the working sites. So this is why we have chosen data collection, so probe data, roadworks warning, and hazardous location notification as main services. The consortium is built of road operators, of course, so public road operators from the ministry, what we call in French DIR, that means Interdepartmental Road Directorate. We have 3 of them. One motorway company, concessionaire, SANEF, and one local authority, 38, which is ISER department around Grenoble. The 2 main French car manufacturers, Renault and PSA, PSA being Peugeot Citroën. Many research institutes, also universities, security experts, because I'll mention it later, but security and cybersecurity is one of the core topics of the project, and also telecom operators, well, one telecom operator, Orange, for the hybrid part. We also work with foreign partners. I'll show you why. You can see here the 5 pilot sites we are equipping, the Île-de-France region, the region around Paris, the Bretagne region, or Brittany, in the western part of France. There we have several road operators of different dimensions who have worked together for public procurement. That's also an interesting experience. In Bordeaux, we have the ring road, which is equipped, and in Isère, mountain roads, and also the Eastern Corridor, which is operated by the motorway concessionaire SANEF between Paris and Strasbourg. And you also see on this map the cross tests we do with our foreign partners. So that means they also have deployments going on, and we send vehicles there in order to check interoperability, and the other way around, they send vehicles to France to check interoperability. This is something that has been successfully done last December with French vehicles sent to the border between Spain and Portugal, and interoperability was achieved. So here are the priority services we are deploying. So data collection, that's the probe data. So we collect position, speed, direction, events detected or declared. Roadworks warning, several types of roadworks warning, also very detailed roadworks such as the exact position of the winter maintenance vehicles and so on. Also rescue and recovery works. Hazardous location notification, that can be either V2V or I2V. The information can come either from the other vehicles or from the road operator. You have here several events that are covered, such as slippery road, obstacles on the road, accident, emergency brake, end of queue, and so on. What is specific about Scoop-ATF compared to other pilot deployment projects in Europe, it's that it has been developed with the car manufacturers. That is to say, it includes what we call CAM emission. CAM is a file that is sent that gives information on the speed of the vehicle, and that can be used therefore by the road operator as probe data for an analysis of the congestion. Also DNMs, that are other files that are sent to cover the events, all the events, roadworks, end of queue, slippery road and so on, based on triggering conditions developed by the Car-to-Car Communication Consortium, which is a consortium of all car manufacturers, well, of most car manufacturers in Europe. It is embedded in the car manufacturer's navigation system, so it's really a series system that is used, and ergonomy specialists have been involved in the development of the HMI. So it's fully in line with the usual standards of HMIs in vehicles. It has gone through an industrial quality process by the two car manufacturers. It's really a small series deployment with 1,000 vehicles per car manufacturer. You have two car manufacturers, that makes 2,000 vehicles, and the 1,000 more are road operators' vehicles equipped that can also work as roadside units, mobile roadside units. And multi-brand interoperability is also covered with PSA and Renault. We have tackled all the challenges of real-life deployment, security, with a fully operational public key infrastructure. That is a system, I will show you its architecture, but it's a system guaranteeing that a third party cannot send messages if they are not in the system, in the club, let's say. Privacy, it's included in the design of the system, and we've worked with our National Data Protection Authority to get their authorization, since the vehicles are really sold to customers. All road operators have gone through standard procurement processes. That means they have different providers, and that means interoperability issues to be solved also. And we've also tested common procurement in one region. Industrial process, already mentioned. Compliance assessment, we've had a validation process. I will show you all the tests that have been done before we give the stamp for deployment. And interoperability testing between pilot sites, between the 5 of them, since they have different providers, and with foreign countries in the cross tests as shown. Scupatev has also 2 sons called Intercore and C-Roads Friends, which are focusing on other aspects. In Intercore, we are focusing on logistics and on trucks. In C-Roads Friends, we are focusing on urban issues and urban services. The key achievements achieved so far. First, we've developed a catalog of the CITS services that is a functional description of all services we can imagine. There can be others. They are organized in 10 use case categories: probe vehicle data, roadworks warning, signage, hazardous location, traffic information, smart routing, parking, multimodality, intersections, traffic management, vulnerable users, and logistics. Here you have an example of the detailed use cases for 2 of these use case categories. For example, you have the famous GLOSA at the intersection, green light optimal speed advisory, that gives you an advice of the speed you should have in order to get to the traffic light when it turns green. Sorry. Here you have the template that has been filled in for all these services. So detailed description, functional description of the service. That's for the functional part. For the technical part, we've developed a whole set of specifications that are filling the gaps of standards, because the standards are not self-standing when it comes to interoperability. The ETSI standard developed in Europe, ETSI being the European Telecommunication Standardization Institute, are not fully self-standing, and we need additional specifications. So we've achieved that, and they are now publicly available on our website. There have been several releases. They have been upgraded from the feedback from development and testing also. On the road operator side, we've developed an architecture that can that is in link with the traffic management system. You have what we call the scoop platform, which is sending the information from the traffic management system to the right roadside units, and in the other way around, it's collecting the information from several roadside units in order to send it to the traffic management system. And you also have road operator onboard units that can act as mobile roadside units. That is to say, they can also send messages as a part of the infrastructure. So patrolling vehicles, for example. This is a more detailed view just to show that the roadside unit actually translate aggregate the messages from the vehicles and translate them into a format that is datex, that is fully without any private information. So it's just an information on the event, and therefore the system cannot, well, the road operator cannot have access to private information. Another important part is the security. In order to avoid that third parties send messages that are, let's say, not real messages, and that can have a bad influence. All messages are signed. So in order to be part of the club, you should be registered in what we call a certificate authority, a route certificate authority, and through that authority you will get certificates that allow you to sign the messages. But these certificates, this time for privacy reasons, are not always the same. They are changing every hour actually, so that you cannot, well, a third party that would intercept the message could not track the vehicle, because actually there is no vehicle identification number. There's only that pseudonym that is changed very often. And of course this public key infrastructure is fully in line with the standards. We've developed also a validation process in order to check compliance of these of the prototypes before deployment. So HC conformance testing, conformance to our specs, also the check of the generation of the logs. The logs will be used for evaluation purposes in order to check that the system works properly and that the benefits are achieved in terms of road safety, traffic management, congestion, and so on. We also check the change of pseudonyms. We check the access to the PKI server. We check the scalability. If the vehicle receives many messages, that it can survive. And also the translation between the DNM, so the events, and the datex format, the format that is fully without any private information, and this is done at the roadside unit level and checked in the roadside unit. So we've checked that through laboratory testing first, then test track testing, and in the end open road testing, and when all steps are approved, equipment has been stamped as ready for deployment. So this is now achieved, and deployment is done on the 5 pilot sites. And on the vehicle side, also, they are now available. So the hardware has been chosen by the car manufacturers. They've developed the onboard unit, so the construction of automatically triggered messages, the relay of messages, because actually a car that is equipped can also relay a message, that is to say the message can hop through several cars that can extend the range of the information. The range of the antenna is actually 1 kilometer approximately. security and check of all incoming messages, and construction of the log files as mentioned for evaluation purposes. Development linked to the HMI also, the prioritization of the messages, because there are also messages existing in the HMI from other systems. The display of the alerts and the triggering of manual messages, because there are also some use cases where we can declare events. It has gone through an industrial validation process. The mounting processes for factories have been defined. So now, since the end of last year, PSA and Renault are selling their cars, and they can be ordered through this address. So now we are starting evaluation. So all the logs that will be received will be used to check that the system has no failures, technically speaking, and also for to assess the benefits in terms of road safety, in terms of accidents that are avoided, in terms also of congestion that is avoided. And in the end, we will have a full socio-economic cost-benefit analysis of the system, socio-economic study assessing possible deployment scenarios considering all the benefits that we will have assessed. So thank you for your attention. If you have any question, I will be happy to answer them. And here you have the website of the project in English, where in particular you will find all our specifications. Thank you.
Thank you very much. Thank you very much, Mr. Ollinger. His presentation covers a wide area of technical features of the project scope at ERF. So, does anyone have any question? Oh, okay, here we go.
I believe you said that the system would keep track of like slippery places on the road to notify other vehicles. Did I get that correct?
So what will happen is that through the sensors of the vehicle will know that the road is slippery. It will then send a message that will be received by other vehicles and also by the roadside unit, and then anonymized and sent to the road operator that through that process will know that the road is slippery at that point, and that can then intervene and send a winter maintenance team, for example.
That was my question, if it went on to the authority and that they could address the road problem.
That's
Thank
it.
you.
Anyone else?
En français.
En français.
Donc sur ce projet, il y aura en tout 3000 véhicules qui vont être en fait vont circuler sur des zones qui sont très différentes. Est-ce que c'est un nombre qui est estimé suffisant pour pouvoir juger des effets sur la sécurité, sur l'économie, comme tu l'indiquais?
Alors effectivement, donc je vais répondre en français. Donc effectivement, c'est un nombre qui est beaucoup plus élevé que dans des projets où on cherche juste à faire un proof of concept, à démontrer la faisabilité. Il y a eu des projets avec quelques véhicules dans le passé. Là, on est passé à l'échelle supérieure. Ça permet de vérifier de nombreuses choses, et notamment les aspects sécurité routière. Par contre, sur certains aspects, on va avoir... alors, ça permet de le vérifier de façon naturaliste, c'est-à-dire sans forcer tous les véhicules à être au même endroit. Pour ce qui est de l'évaluation des impacts sur la congestion, donc on s'attend à des impacts positifs sur la congestion. Par contre, là, en ayant les véhicules disséminés sur l'ensemble des routes de France, on risque de ne pas trop voir d'effet. Et donc c'est pour ça qu'on va, pour évaluer l'impact de la congestion, on va scénariser. Donc on va mettre un certain nombre de véhicules au même endroit, les faire communiquer entre eux et voir les effets que ça a. Voilà. Donc il y a des endroits où on est obligé de faire du scénarisé dû au nombre peu élevé de véhicules, mais globalement, l'idée c'est que c'est quand même une échelle qui nous permet d'y voir clair là-dessus.
Next. Okay.
Excusez-moi en français encore. Vous insistez énormément sur la confidentialité, sur cet aspect un peu anonyme. Vous ne pensez pas qu'à terme, dans quelques années, des tentations relativement sécuritaires en tout genre fassent que votre système hyper protégé aujourd'hui devienne en fait un Big Brother ou un outil à PV, un outil à contravention qui risque d'être pire que la sécurité aujourd'hui?
Alors, c'est tout le contraire. C'est-à-dire que le système, en fait, comme je le disais tout à l'heure, associe à chaque véhicule un pseudonyme qui est changé régulièrement. Et donc, il est impossible d'inverser l'algorithme, y compris pour les forces de l'ordre, d'utiliser le système à des fins pour les forces de l'ordre ou un Big Brother, à des fins de dénonciation de comportement à risque. C'est pas l'objectif du tout. L'objectif, c'est bien d'améliorer la sécurité routière et d'apporter du service. Donc le système est conçu pour ça.
Et si la loi change ?
On s'inscrit dans la loi actuelle.
Okay, thank you very much. Okay, thank you very much, Eric. Then third speaker is Mr. Steido, Mr. Kirk Steido from United States. He is currently working as the director of the Michigan Department of Transportation, overseeing a $4 billion budget of the state, responsible for management of nearly 10,000 mile long